All right, so right here, let's close up on everything that we've just learned here today on our sum of squares Pythagorean theorem. We're using our prerequisite skills here, working down, using our bedmass, and solving, which is using our bedmass backwards. So when we take a look at this first triangle right here, we have two side lengths. These are the legs. These are the sides that are not the longest side. That is, these are two side lengths that connect to the right angle. And if we take the square of each of these sides, so if I draw a square on each right here, then the area of this square, well, that would be 3 by 3. That's an area of 9. And if I take the square on the other side, well, that's a 4 by 4. That's an area of 4 times 4, that's 16. So the sum of those two areas, that is, if I add those two areas up, they will equal the sum, or sorry, they will equal the square of the third side, that's of the hypotenuse, and that would be a 25. I get that 25 from a 16 plus 9. Well, 16 plus 9, that 25. If I square root that 25, I can find the side length of each of those two sides because it's a square, not a rectangle. I'm working with a 5 by 5 square, which tells us really that this triangle we initially started with has a third side length. Its hypotenuse side length is 5 right here. Oops. There we are. Now, if I'm showing it that way, that looks great, but I can up the difficulty right here. So I'll ask you, pause the video right here, try out, come up with the third side length right here, and then we'll do it together and I'll show you a bit of a nicer way to lay out our work here. Give it 3 seconds here, pause the video, try it out on your own, because here we are going right through it. Well, the square of this side, I can find that. If we call this side, we can call it side A and this side B. The two short sides will be sides A and B, and then we can call that third side, side C. If I take the square of the first side, that's A squared, and I add it to the square of the second side, that's B squared, I come up with C squared right here. Fantastic. Well, A is just a side length of 5, so that's 5 squared. Here I'm using my prerequisite skill working down. 5 squared plus 12 squared equals C squared. I don't know what C is yet, so I'm just going to leave it right there as C squared. Well, 5 squared, that's 25. 12 squared, that's 144, into my calculator there, is equal to C squared. Again, I still don't know it, so I'm just going to leave it right there. And my 25 plus 144, I'm working with 169. Well, that's great. I could write that right here. That's a trap. This isn't working down. This is working across. And if I do that, all of a sudden, I lose my C value, the one I'm looking for. I lose that in my equation. So I don't want to write that 169 here on the right side. I want to write it on the left. There we are. We're working down. 169 equals C squared. Well, that's great if I want to know C squared, but I don't care what C squared is. I want to know what C is. So I can square root both sides, that is doing the inverse operation of that square operation there, leaving me with just C on the right side and the square root of 169. That's 13 right here. Good work. That means our third side length is 13. So I want you folks, again, pause the video, try it out right here. Try using this algebraic approach where we're laying it out like this, but just notice right here we're not finding that longest side. Right here we're finding one of the two shorter sides. Give it 3 seconds here and then you'll see our solution popping up. And I'm working right here. Okay, so I'm going to set it up the exact same way, and that is with my A squared plus B squared equals C squared. And now that I have that, I want to fill in what I know. Well, I know 12. I can call that A. Okay, so that is 12 squared plus B squared. Remember, our A's and B's are the two shorter sides of the triangle. That is the two sides that are connected to the right angle right here. So I need to leave that as a B squared. I don't know what that one is. I do know the third side, the longest side, that's a 19. Fantastic. Well, from here, oops, don't forget my squared right there. From here, I can evaluate my 12 squared, that's 144. My B squared I leave as a B squared because I don't know what B is yet, and equals my 19 squared. There we are with whatever 19 squared is. Let's throw that into our calculator, 361. Okay, fantastic. So if I'm trying to find B squared here, I'm going to need to solve, or really I'm trying to find B. I'm going to need to solve for B. That means I'm performing my inverse operations in order to evaluate that unknown value. Well, my inverse operations, that's my bedmass, oops, that's my bedmass right here. I need to follow backwards because I'm trying to get this b on its own. So I'm going to work with this addition first before I work with that exponent, the square right there. So my opposite of this addition is subtraction. That's negative 144 on both sides. I throw this 144 minus 144. Those will cancel out. That was intentional. I'm working with b squared is equal to 361 minus 144. I throw that into my calculator. B squared equals 217. Now I'm in a similar spot to where I was before. If I'm trying to find this unknown b value, I can square root both sides. Good work, us. That is an b that's left alone there on the left side. And my square right here, 217, into my calculator. 14.7. Well, hang on. Am I expecting 14.7? Can I get a decimal number? Absolutely. There's nothing wrong with getting a decimal number. Most triangles you're working with, most side lengths, you'll have one decimal number involved. We just had two unique triangles here that come from our Pythagorean triples. So what I want you to do right here, we have two more. I'll encourage you, if you feel comfortable working down like we did on the second two triangles up top, on the red one and the purple one, I want you to try out working down. That is working with an algebraic work. But otherwise, if you're not comfortable working down just yet, draw in your squares and try and figure out the unknown side lengths. Give it 3 seconds here, and you'll see a solution popping up for the triangle on the left. There we are. Nice work, folks. Where we find C, our unknown hypotenuse, that's the longest side right here, is equal to 25. Give it 3 more seconds, and you'll see a solution popping up here for the triangle on the right. Be careful which unknown you're looking to solve for, whether it's the hypotenuse or whether it's one of the shorter sides. And there we are. I've called my unknown side length b. Remember, a and b here are interchangeable. If they're the shorter sides, it doesn't matter which one you use there. But we end up with an unknown side length of 25.2. So there you have it. If you have been through these, then you're probably feeling pretty darn good with your sum of squares. Nice work, folks.